And since I have all these batteries already ready for going up to the second floor, it's time to actually start carrying some of the batteries up. And hopefully I will be able to clean this mess up here, because I have been totally busy with preparing the batteries with a new BMS system and everything. So let's carry it up. The first part would be roughly, I would say, 250 kilos of batteries. And then I have another 250 kilos of batteries over there that are ready as well. So that's a lot of batteries to carry up to the second floor. So let's get cracking. So basically I have this interconnection here, and I have an M8 screw. And I thought I have a washer instead as well, but I didn't. So washer, this one, and it goes to the battery. And next step now, when we have come this far, when we actually have two of the rows in there, is to actually measure the packs and make sure that we can actually tie them together. I did this before and that was fine, via measuring, but you still need to cross-check it so you make sure that nothing has changed or you did change it or anything like that. So by checking here 1319, that one is too high. No, 13.3, 13.2, 13.3, because if they aren't close enough you cannot hook them up in parallel. It will rush too much current between them. 13.2, I think I should have had them hooked up properly. Let's see. When they all are together, it's just a matter of adding the last row. And this is the row with the actual BMS slaves that will be measuring this. Next part is to actually wire the batteries up to the terminal here that actually goes down to the inverter. And what's important then is actually to make sure that you use the same type of wire and the same length to all the strings here. So basically, even though this one may be short, you should use the same distance of the wire here as the other one if you want it to be 100% even. This is especially important if you have voltage drop in the cables and you don't have really thick cables, because then it could affect the strings and actually pull more current from this string here than this string down here due to the voltage drop. Especially important this is when it comes to this type of batteries, because this type of batteries doesn't drop much and it stays roughly the same voltage all over the capacity. So depending on your application and how you do it, I recommend to use the same length of cables and the same wire everywhere, because then you will get even results and no real problem in the future. I'm going to measure out now how long cables I'm going to need here. And I think that should be fine, because then I will be able to use it both on the top and the bottom. So then it's just a matter of cutting the cables, and I'm using 16 square between the batteries, and I'm using 25 square millimeter from the strings to this terminal, and then I'm using 50 millimeter from this terminal and down to the inverter. So let's go and crimp the cable and mount them. Wires is what I recommend because it's a lot easier to work with. So if you can go and fetch some silicone wires, it's a lot easier. Though they are a little bit more expensive. And currently we have those two down bangs connected to this here. So now it's time to actually go down and start connecting the wires together so we can get the wires to the second floor as well properly. So before we actually start working here, we need to make sure that everything is shut down. I did connect my AC out to the secondary line, so that's done. It's not powered from this anymore. And then it's just a matter of shutting it down, and you do it like that, and that goes down. The battery is already disconnected since before, and that's shown here as well, and it's on the computer, that's shut down. Next part is actually to shut down the inverter itself, and to do that I disconnect the PV, and you didn't see that, but when disconnecting the PV it's only the utility left, and that's why this inverter sounds a little bit. And then I go and shut down that as well. So in a couple of seconds the inverter will shut down. It's just running on the capacitors inside of it, so it shouldn't take long. There we go. So here we have the old cable, and here we have the two new incoming lines. They are not hooked up to anything yet, so no problem touching them. And I need to add a new switch, and I'm also going to add a bus bar. So basically we have the switch here that is going to be the one deciding if we're going from bank 1 or bank 2. Bank 1 will be the main bank, and that's the one on top here. And bank 2 would be the 18650 laptop power wall. That one need to go here somewhere, and this nice thing here is what I just made up earlier, would be the one distributing the positive side. And we have the common here and 1 and 2 there. So that's the input line, and we will have one of them going in there and the other one going out there, and that's where we decide which one to use. We need to mount this, and we need to mount this one for the big inverter, and then we need to hook everything up. This would be the positive here, and this would be the negative. The positive is the one that actually is always connected to every device, kind of, and the other one will not be that. The first one would be this one here, and that one will go into this. Then we need something to hook those two up with each other. It's always difficult to get on the right place, this, and I think I'm going to do that. So basically I need to hook up both inverters here. Let's mount this in place so we know roughly where everything should be. And it may seem to be overkill to have two switches, but this one is actually only used for switching between the banks, and this one is used to actually switch on and off this inverter, and the other inverter over here have its own switch. This will be changed a little bit later on. Something like that. I'm pretty happy with that. Next one is to mount this one here. Before we do that, we also need to tie both inverters to that one. And this is kind of how it looks when it's done. As I said, this one will be moved later on. So this is new, going into first this one and that one there. And then we have a distribution over here for the positive side. Two cables here I cannot do much about, that's the main connections, and since they're going up, that's how it is. I would have loved to have them just going down instead, but I cannot do much about it now. So basically the connection down here is now done. Next part is actually to go back up and connect the batteries to the inverter as well, and then also hook in the BMS. We have the incoming cables in this end now, but this is the positive and we need to get it over there. I have the cable here and it's 50 square millimeter as well. This cable will be tied on the back side up here. That's a little bit tricky to get onto as well, but we'll do that later on. The tricky part here is actually to get those together. If I were thinking of this before, I should have used the full length here, but I don't have that cable. And to buy another cable cost me around 70 euro, so I will not be doing that. I will be actually tying them together here. And to do that I need to crimp another lug here and be able to... The next one is the negative one here. That needs to hook up to the negative side, and I'm going to do the same as on that side. I am actually going to mount it on the inside here as well. So let's move that one. I need to crimp one wire there and one wire to that bottom one. Let me get those. Always make sure to take your contacts and make sure that they sit pretty hard, because otherwise they might generate heat instead. And the last pieces are the ones here, of course. Now it's time to measure that we get the correct polarity and everything down here. And once again, the one in here is the positive. Let's see if we can measure it. And that one negative, 53.1 volts. And that looks fine. Let's make sure that all the contacts is sitting properly. And it's now time to start up the inverter. So let's do that. So basically we will start with the grid, and the inverter goes on. We'll start up the 1 PV more. It takes up to 1 minute to synchronize to the grid, to make sure that the grid is stable. Now it's set the utility, and it's set to the load, and it sets the PV. If I just can get to start up as well. So it finally turned on. It took some while. I'm not sure what the time is it takes for it to actually go into start mode. Now it's actually charging, so it goes from the PV to the utility and to the load. I have no load connected, so now it's actually time for me to turn on the battery, because the battery part is shut off, I think. No, it isn't. There, the battery is on. So now it's trying to hook in the battery.
And that's it for this video. The battery was hooked in fine and is now working. As you can see on the image here, I have 2 of the 4 rows installed and it works just fine. I will be doing another video where I actually show on paper on how I have connected everything up. But this video is already way too long and therefore I will not include it in this video. So guys, if you have any questions, just feel free to write them down below. If you have questions on how I did connect it up, or when I'm showing the rest of the batteries, just hold on. I am editing the videos right now and they will be up in short. So once again guys, if you haven't already subscribed to my channel, don't forget to do that. And if you want to help me out on my journey to actually helping you guys out on how to become a better solar user, don't forget to sign up to my Patreon and become a Patreon user, or use PayPal directly. You can also use any of the links below to buy stuff that I have out. So guys, again, thank you and see you next time. Bye!